Applying the cosine rule. Last lesson we looked at deriving the cosine rule, and we looked at a proof which showed where the cosine rule comes from. Now there's two scenarios or two situations where we can use the cosine rule. If two sides and an included angle are given in a particular triangle, we can use the cosine rule to find the length of the third side. Or if all three sides in a triangle are given, we can use the cosine rule to find any unknown angle. And as part of our lesson yesterday, we noted each of these into our exercise book. So now we're going to have a go at applying the cosine rule in a couple different examples. So in example 3, we are asked to find length BC. So another method that we can use to label sides, we could call this side BC, or we know that by convention it could be lowercase a. So since we're trying to find BC, that unknown length, we know that we need to have two sides and an included angle, and then we're able to apply the cosine rule. So here we can see that since we're given BC and angle A, we are able to apply this to find our unknown side length BC. So A squared is equal to B squared plus C squared minus 2BC cos of A. A squared will be equal to, now B is 13 squared plus C is 11 squared minus 2 times B times C times cos of 42, and therefore A, not A squared, will be equal to the square root of everything from above and taking care and applying using your calculator, you would find that A is equal to, or approximately equal to, 8.8 centimeters, and that would be our final answer. Okay, now in example 4, we are asked to find angle BCA. Again, this is another way of signifying which angle we're talking about. So BCA, you always look at the middle letter, and that essentially is telling you which angle we're trying to find. So this angle in here, BCA, you could also call it ACB. Now remember we rearranged the cosine rule to this form here, and we can use this to find our unknown angle. So since we have 3 side lengths given, I can find angle C. Then we just need to substitute our values in. So we know that cos of C will be equal to 5 squared plus 8 squared minus 7 squared over 2 times A times B and you would put this into your calculator, and it turns out that this equates to 1/2. Therefore, angle C will be equal to the inverse cosine of a half, which is equal to 60 degrees. So therefore angle BCA measures 60 degrees. Now we're asked to find the area of triangle ABC, and again we're going to be applying what we learnt in our last lesson to find the area. So we know that area will be equal to, remember we now have an angle and two included sides, therefore we can apply our formula, which is a half times 8 times 5 times sine of our included angle, which is equal to 17.32 centimeters squared.